just to get this thing rolling, a couple of years ago, we set up a planning program here, and the idea was to set up planning that had studios and was physically oriented, as opposed to planning that is policy oriented, actually teaching people how to physically design cities. And basically, it's a continuation of landscape architecture and was going to involve studios. But the planning profession, in order to get it accredited in the profession, all the faculty that are teaching and planning have to have a doctorate, a PhD. So the conundrum was really, how do you find people with PhDs who have practiced? Because you really need people who have practiced in the profession to be able to teach the kinds of studios that we were trying to promote. And so I went looking across the globe, and I found her. And just as a quick background, Rosanna graduated from Simón Bolívar in Caracas, Venezuela, and she practiced for a number of years in the Orinoco Basin as a planner. And then she came to the US, and she went to the University of Florida. That's something we've never held against her too badly, where she studied and got her master's in planning, and then went on to get a PhD in interdisciplinary ecology at that university. And at that time, the idea of planning and ecology combined itself. She went into a lot of research in the Florida Everglades, and then spent years at Florida doing research, and then on site in the Everglades, or with the Everglades, the Conservancy, and the restoration of the Everglades. And I guess that was under the Clinton administration, probably about that time. In any case, she's worked there. So she's had at least 15, 16 years of professional practice before she came to us. So, and of course, her specialty is what she's going to be underlying here. Her specialty is in the remote sensing, GIS, ArcGIS, the design softwares and things like that. Ironically, I'm an idiot when it comes to that particular subject, admittedly, but when I was getting my PhD, I was writing the software that led to that. So I don't know how to operate the machine, but I sure as hell know what the software looks like. So it was an age-old practice. So with that, we're going to open the show up to our presenter, Dr. Rosanna Rivero.
Thank you, Jack. Well, thank you everybody for being here. Thank you for that very kind introduction. And once again, thank you for spending the afternoon learning a little bit of the things that I have learned through my few years of experience in this. So let me share my screen for a second. Let me do something first. Okay. Okay, good. So everything good? Great. Okay, well, you would imagine that after 2 years teaching online, I get used with this technology, but it's weird in this environment. So, well, once again, so today's presentation is about, how I have experienced through these years, this whole geospatial technologies. But I also wanted through this presentation kind of honor the pioneers that we had in the field, that many of them came from this, this same school that we are, from, not from this building, but from the school. And I spent hours talking to Bruce Rader, which is one of those alumni that have been influential. And as I mentioned in the abstract that I wrote for this presentation, one of the points that I'm trying to make, and hopefully I will make through this presentation, is what an important, even though we call these technologies, geospatial technologies and geographic information system, really planning and landscape architects play such an important role in the evolution and even the evolution and the conception of these technologies, that I really wanted to use this presentation to, honor their legacy. So funny story, when I was, putting together the presentation, this is a photo that came right away from, I don't know, Microsoft template, but it is a beautiful photo. And I kept thinking, If you are one of those persons that when you're flying, you ask for the windows and you will go the whole flight looking down, that would be me, and I love that. So I guess that's one of the reasons I came into this field is, just to look at this type of beautiful environments. I wanted to start with a very brief introduction about what geospatial technologies encompass. These images are not mine, these are from Imagery, but basically encompass the whole world of geographic information system that we call GIS nowadays, remote sensing, the use of aerial photography, satellite imagery, LiDAR, and other technologies to capture from distance, whether it's a short distance or a very long distance, the environment and not only the visible, but the invisible part of the environment that we cannot capture with our eyes. Of course, the whole world of three-dimensional technologies, how do we bring those technologies into that more powerful capacity? And finally, something that I think is a very powerful technology that we have in ourselves nowadays, that we forget how to navigate without this, that is the GPS. And I was just reading an article from Lori Jordan about how this very complex technology that we use in our phones is so complex. I mean, involve a lot of moving parts, but we just use it and we don't even acknowledge how complicated. I mean, it's so easy. So he talks about the illusion of simplicity, which is something that I'm going to bring back again later. Can you all hear me well? Okay, good. So this is just a very minimalistic idea, or I guess a slide that really just bring the sequence of things that we do in our disciplines and many in other disciplines. We basically collect data, manage data, and pre-process data before we use it. We are very strong in analyzing and synthesizing that data, representing, ultimately using that for designing and planning, and then visualize, communicate, disseminate, and collaborate. And I just put kind of the two extremes of this. I mean, just very simple data collection all the way to things that we use nowadays, in the geospatial cloud. But at the end of the day, and some of my students will probably laugh because I just used this the other day and they criticize my use of triangles. But at the end of the day, it all goes into, filtering that amount of data that now is even larger with big data into information, knowledge, and ultimately the wisdom and the capacity to make decisions, which in the case of our professions as designers is critical because we're basically not working for ourselves. We always work with some kind of client, some kind of organization. Part of what we do or we try to do is helping them in many cases, making decisions in some case, in some kind of collaborative environment, which is something that I'm going to talk about later. So I wanted to go back in time because, as I said, my claim is that these planners and landscape architects play a very important role in the development of these technologies. And this is a very simple article from the 1923 New York and its environment survey, if some of you are familiar with that. And the idea of mapping very complex information and many layers of information has been always there. So we use back in in the early 1900s, we used these very kind of complex combinations of patterns, and we didn't have colors back then, and graphics and things that probably in a GIS environment it probably would take us, I don't know, maybe half an hour just to make. But the idea is that we're trying to convey and bring many layers of information. So and there is a great article from Lori Jordan and Carl Steinitz that explain how as early as 1912 we have design professionals that found this idea of mapping, overlay, mapping all that complexity of information, trying to make it relevant for decision making. So Another, of course, influential author in that realm was Ian McCarthy, who wrote a book called Design with Nature in '67. And even though we're talking about 50 years after the initial ideas that I mentioned of mapping overlays, he brought something else to these ideas, and it was this about using a combination of mapping, but also qualitative and quantitative criteria into the process to talk about, for example, compatible land uses or attractiveness and vulnerabilities of different type of systems. And of course, bring basically the idea of systems that was beginning back then with the whole environmental movement and maybe some of the social movements. So I guess we were able to communicate to the world that here we have the tools to help society overcome, hopefully, some of those problems that were present back then. And that if you think about it, are back. I mean, we're still talking about race. We're still talking about long-term environmental problems. So this is still a very valid idea. And I wanted to go back also in time to Harvard, because the history of geospatial technologies and GIS there are books written about it, and there are many perspectives. The Canadians were doing massive land inventories, and they were also, using GIS. But Harvard played a very important role in the mid-'60s. They get a large grant from the Ford Foundation to give funds to this lab, the Laboratory for Computer Graphics in the School of Design. And basically, this is the moment when, of course, I mean, think that around that time we have the confluence, and I have a diagram that's going to show that, but basically the confluence of computers, the beginning of the computer science, era, satellites that are being launched back then, and then this spatial thinking and design thinking that was embedded in all of this. So here we have some of the scientists or the planners and the architects working in the lab using kind of traditional technologies and ways of thinking, but also trying to bring some of these conceptual and sometimes qualitative models into the thinking of that spatial thinking, trying to solve problems. And pay attention to this photo, because I'm going to talk about that later. So basically, in a very short time, less than 10 years, between mid-'60s and '70s, we go from doing things manually, quantifying amounts of land, to using computers one way or the other. Maybe not as accessible to everybody, because we didn't have yet computers having done science. We actually have large computers doing very sophisticated processing, but already thinking in an amount, many things that had to be done when trying to conduct inventories and conduct all kind of analysis. So this is what I was talking before. I mean, this is a moment where we have not only powerful computers, we have NASA launching the first satellite sensors back in the early '70s. And then we have the thinkers all together, trying to address problems that, as I mentioned before, were very relevant at the time. So, and think about, once again, situate all of these in the middle of the '60s and the '70s, such a turbulent era that with very various needs. So I wanted to bring this quote from Carl Steinitz, which is the person that you see here. We were lucky to collaborate with him in a geodesign project that I'm going to explain later. But I like this quote, and I know that there is a lot of text here, but I wanted to bring this quote just because, once again, between the '60s and the '70s, we went, or that lab went, from basic representation, basic mapping, just display of a few variables, to more complex thinking, bringing or merging mapping and statistical techniques for example, trying to understand how allocation models to determine population increase, and then from there, how to bring industry, residents, recreation centers, and then the whole transportation network. So very, things start getting more complex in the type of analysis that can be done with these computer applications. And then finally, in the 70s, partially because of, kind of the ecological, the environmental movement and the social movement that I mentioned, this group started looking at other disciplines and other engineering professions and scientists, and the need for more predictable analysis and for better models come into place. And we start seeing, prediction models that bring, more complex equations into the mapping process, I guess. But something very important that happened then is that somehow two different type of technologies start developing in parallel. No? They kind of co-evolve. And one is GIS, which in essence, or at the very beginning at least, had the language of points, lines, and polygons. Just as we see here, points, streets as lines, and parcels as polygon. And then the whole world of remote sensing and imagery, which is measured in pixels, rasters, and even point clouds. So kind of two parallel worlds that led later to two different type of software. And I think UGA and Georgia Tech, so in general, Georgia played a very important role in that, particularly in the remote sensing, with a couple of main players. First of all, a couple of alumni from here that I just mentioned, Lori Jordan and Bruce Rado, that went on, former students from Carl Steinitz and part of that lab that I just mentioned, that went and founded ERDAS, Imagine Software in Atlanta. And then the Geography Center for Remote Sensing, who has been a great partner through the process of, doing those kind of things. So these are a few images, selected images. We could have a whole presentation just about all the great contribution that these two, Bruce Rado and Lori Jordan, brought to the remote sensing world. But one of the things that I think I would like to highlight is that here in Atlanta, in their small office, they were the ones that produced for the first time in the US a map, a vegetation map, or a land cover map of the state of Georgia. So Georgia was the first state that get a land cover map, and it's what you can see here. And then NASA basically, and I'm sure that Bruce can probably tell the story better than me, but this is a van that NASA had in Washington when they were, launching one of the first satellites, Landsat. And the software that they carry there in that little van was that software that was developed here in Atlanta, in their offices in Atlanta. And they basically went on and worked in many projects, first through the Department of Natural Resources, and then through their own company doing consulting to every single level you can think of, from government and very high levels of government to of course, environmental. And these are some of those pioneers or protagonists, well, I guess a few years later. So Carl Steinitz is this person here that you saw in the previous photo. Jack Dangermond, who is here, went on and founded a multi-millionaire company that is basically the software that you're using in the labs and the one that some of you are learning either with me or with Professor Smith. And then Bruce Rado and Lori Jordan, as I mentioned, they went on and founded ERDAS in Atlanta. And Lori Jordan is currently the director. He's working with Esri as the director of the imagery sciences. So I think if I have not made my point by now, how influential this generation of planners and architects were, and that this is a software that every single discipline that has to conduct some kind of geospatial analysis nowadays is using, there is something to say about the way this design thought process came into place in the evolution of this software. As I said, not only, of course, there were not only planners and landscape architects. The center, what is now the Center for Geospatial Research at the Geography department, was also instrumental around the mid-80s in mapping, continue this idea of mapping different type of landscapes. And this is an image of a map that they produced based on remote sensing from this is just a portion of the Everglades region. And that was kind of my link to them at some point, because that was part of the job that I did for about 10 years between the University of Florida and the Everglades Foundation. And I had the opportunity to meet Margaret Madden, who is the director of the center back then. And I never thought that I was going to end up in Georgia, by the way. So that was, that was kind of very exciting. And I always keep telling her. And I did many projects with the Everglades Foundation and with the University of Florida, some of them using kind of reconstructing historical environments. This, for example, is Lake Okeechobee. And this is kind of the whole South Florida Everglades region back in 1913. So this is basically a vegetation community map that was not digitized up until then. And then I use satellite imagery to develop prediction models to look at increasing nutrients and phosphorus. And this is one, it's just a sample of many projects that I did back then. But my connection to Florida was very important, and I'm going to explain in a minute why. But something that I haven't talked about yet, and I wanted to bring now, is the whole idea of geodesign, the geodesign framework. And I, once again, violate the rules of good, presentation making and brought a lot of words here. But I wanted to do it because this is a person that I admired a lot, Juan Carlos Vargas Moreno. He was also a Harvard student from Carl Steinitz that also went and founded a company that is a consulting company in Boston. But I thought that he expressed here very well kind of that flow that I brought from these ideas from the 60s to the 70s and later. So GIS ought to serve as medium for the exploration of spatial concepts in design and planning problems, where various design agents have to manipulate and explore spatial concepts. So sketching, diagramming, and 3D modeling are among the most powerful, useful mediums of inquiry and exploration in design in our disciplines. So GIS must integrate conceptual ways to manipulate space in the way we do manipulate other mediums from design and inquiry. And geospatial, back then he was talking about spatial Delphi because he was talking about this sort of participatory consensus building type of techniques, is based on the assumption that group judgment are more valid than individual judgment when you're conducting some kind of design project. And that participation in this context entails integrating a variety of stakeholder positions into the design and planning process to propitiate more democratic and inclusive solutions, aiming to integrate their vision and knowledge into decision making. And I think this sentence is key to what we do in geodesign. Whether we are there yet, I'm sure that we still have some ways to go. But I wanted to go back to Florida because geodesign has many flavors. And one of them is the one that Florida started developing back in the 90s. And I was lucky enough to be a student with these two great team of professors, Peggy, Margaret Carr, and Paul Zwick. They founded the Geoplan Center that was kind of a hub of geospatial data for Florida. But they got funding from the Department of Transportation and a few other agencies, I think EPA, to start experimenting. You remember that triangle that I had about data to information of that. So now we have all this great data for Florida. What do we do? And what do we do with a state that is growing very rapidly and that we need a very quick ways to make decisions? So I was in some of their earliest studios. They were conducting studios just like we are here, but more very GIS intensive driven. And a few years later, they wrote this book called Smart Land Use Analysis, Land Use Conflict Identification Strategy. And I borrow a few slides because they came to UGA a few years ago, and I borrow a few slides from them to kind of explain the concept. So as I said, I mean, Florida has been growing very rapidly, just the same things that we're experiencing in Georgia now. So basically, we're just kind of shifted in time. And what happened is that there was a very strong pressure to identify key pieces of land that would ensure connectivity in the state. So they started in the 90s talking about the closed Florida Greenway and, kind of developing a master plan. Later, talking about the Florida Ecological Greenway Network. And then in the last few years, they have been also talking about projection for long-term projections of population and then sea level rise, of course. I mean, we're talking about Florida, so there is no way that you can avoid that. So part of the work that they did was to use this framework that I'm going to explain in a minute to identify critical pieces of land, critical linkages between, large already conserved areas, just like the Everglades, the Apalachicola in the north, the Okefenokee, and the Okefenokee is here, and a few other areas, and how to provide that for the sake of wildlife movement, basically all the recreation too. I mean, all the kind of the nature-based and not nature-based reasons to do that. So basically, the idea of this framework goes from identifying, of course, a problem, which in this case is, we have a state that is growing or a region, and think about regions like Orlando that, in the span of 10 years really went completely out of control. So the first thing so going back to that quote that I had before, the first thing that you need to think about is this idea of stakeholders. So the way they conceptualize this is that you are basically developing different suitability models weighted according to different stakeholders. So in this case, they were looking at conservation, agriculture, and basically urban and suburban development. And from that, you develop a set of criteria that you're going to use to either measure some kind of attractiveness or vulnerability to kind of map different conditions and based on some kind of ranking that you establish. The stakeholder idea comes later when you determine how are you going to weight that criteria. And then that's when you can identify this idea of conflict. Basically, you have different type of land uses or stakeholders competing for the same areas, for the same space. So it goes back to the idea that, of course, we have limited space and we have competition. So they came up with this idea of a tree code that will give you, the basis to assess conflict, major conflict, and basically represent that and map that, and use that as a tool for stakeholders, depending on who are they talking to basically use this set of information to make their own decisions. So remember that this is in certain ways about collaborative processes and almost, I would argue that also empowering, stakeholders. And basically part of this idea is, as I said, to establish criteria to determine, for different type of uses, and to ultimately allocate areas for those land uses based on that element. And we use that. So this is where I guess I come into place because when I came to UGA, I think it was maybe a year or two after I came, so about 2014, an opportunity came up to partner with the Center of Geospatial Research and to through a program that NASA has that is called NASA Develop. And basically what they do is that they give a 10 to 16 week internship to students. They don't need to necessarily be UGA students, to work in a project where they need to use NASA satellite imagery, but that it should have a partner and some kind of decision-making component. So we use an existing connection between the Miami-Dade Park and Recreation and the Trust for Public Lands. And we developed basically, a project with them that it was intended to look at this western area between the Everglades and the city of Miami to explore the possibility of establishing, a greenway project. No? And we did that, adapting that LUCI's process from the perspective of recreational uses, protection of natural resources, and agritourism. So I'm just gonna, let me see how I'm doing in time. Okay, so I'm just gonna go, try to go briefly through this. So here you have kind of those different stakeholder driven maps that are kind of recoded to offer this idea of conflict that is gonna let us allocate different land uses. And in some cases, it's also priority for, as I mentioned before, for conservation. So these are a few images of the students. Actually, I think we had a couple of CED students here in the group. And of course, this involved the use, as I said, of NASA imagery. So Miami-Dade had land use that was not completely updated and didn't account for some of the recent changes. So we use satellite imagery to and different type of algorithms to create new maps that will be incorporated to that. We had the opportunity to run another project, this time with the Nature Conservancy. And this was in Atlanta. Well, actually, yeah, the whole region, the whole metropolitan area. And in this case, the idea was to identify priority areas for green infrastructure, reforestation targets, basically. And in this case, we brought somebody from another department to run this soil water assessment tool. But we basically use kind of the same framework, LUCI's. So this is one example of one of the objectives, minimize untreated flow from impervious surfaces. So this kind of summarize a little bit the type of layers that we're incorporating to the process. Distance to waterways, floodplains, land cover, socioeconomic criteria, also neighborhood age. And that gives you kind of an idea of, the type of things that came into place. And the results of these have been and continue being used by the Nature Conservancy to prioritize, to identify, areas where they want to focus for their efforts. Another flavor of geodesign came as an opportunity in 2015. And this was an opportunity to partner with Carl Steinitz, the same person that I showed in the photos earlier in Harvard. And it was a different type of framework with commonalities, because it's also based on this idea of stakeholders coming to some kind of negotiation to visualize, to understand the future of a region. And in this case, the region that we chose to experiment with his ideas was coastal Georgia. So we use, a couple of elements, just a couple of things briefly from Carl kind of ideas about geodesign. First of all, that you need to incorporate different, the science, you need science-based decisions, but you also need the people from the place and the design professions all coming together into the same table. And of course, you need to bring information technologies, because it's one of the reasons, or one of the ways you're trying to use or bring these decisions into place. And the second aspect of this is that rather than going like in a very linear process, you go through iterations where the first one, the first iteration, you're trying to kind of answer the why do I need the study? So you are framing the problem, trying to understand the context, and you do that by going, almost like going again to the triangle that some of you hate so much, going from representation models, which is basically use of data and cartography, all the way to the evaluation models, those where we use criteria to assess, the quality of an area. And then from there, you start looking at the future, how the area is going to be altered, which are, in essence, change models. What difference is that going to produce? And then ultimately, who is the one that is going to make decisions? And you do this through iterations, because once again, you start first addressing the why and doing like a very conceptual design of the process. In the second one is that you really specify the methods, and you need to understand the stakeholders, identify them and understand what are their perspectives in order to continue kind of conceptualizing the process. And all of that is done before you finally implement. And generally you implement these by producing some maps that are going to some kind of online environment where later you can bring stakeholders through a workshop and have them basically use the data through their, for their own benefit. So this is kind of the online environment that we use. He developed this, or a PhD student, Richie Balal, developed the online platform that it was basically a reflection of Carol thinking. And basically what it does is that one of the first things that you do is you identify systems that are very specific to your problem and your study area. But then later on in the process, you basically act as a stakeholder and try to bring designs and projects and ideas into a design that everybody's going to discuss and hopefully negotiate for some kind of agreement. So this is the first one that we did here in Athens. So this is basically in this process, we have people from geography, from forestry, even from other Georgia universities. We have people from North Georgia. We have people from the area. And it was very, very diverse. We had students, we had professors. And we kind of did this at a multi-scale. We look at Chatham County in coastal Georgia first. So one county where Savannah is. This is the city of Savannah. And then we look even closer to Warnslow, which is an area, a protected area of significant, significant historic value for the college. So we kind of look at both. And these are some of the areas that we identify as needed, climate, ecology, surface water, groundwater, historic, cultural, tourism and visual. And then kind of we look at this from the perspective of vulnerability in certain way, and then attractiveness, which is basically agriculture and forestry, housing, commercial, and transportation. And through this process and the use of this kind of innovative online platform, we were able to produce a plan that is still kind of a conceptual plan. It's not something that you can go right away and implement, but it's something that you can use to start fine-tuning, this as a future, comprehensive plan. The process was so successful that the regional commission of coastal Georgia got funding from the Department of Community Affairs, and we did a second one in 2016. And in this one, we got even more ambitious, and we decided to look at the whole 10-county region. So here, and the kind of the twist in this case is that each county had kind of their own, became their own stakeholder, and they had to negotiate among themselves, between themselves, and then, as a region. So this is a very, I don't expect that you will read any of this, but this is kind of a very, very complex synthesis of the whole process right from the beginning, when you identify and map the evaluation maps for the 10 systems, to the area where all of the participants draw and sketch ideas for what they want to see in the future. And then this area where you have the decision models, where each group of stakeholders decide how to prioritize, and then an area to combine, and not to combine, to compare and possibly combine. So it's a very interesting process because there is no ownership in this process. I mean, basically, whatever you bring to the table belongs to everybody. There is no. And the other thing is that these tend to be very rapid processes where they are not intended to bring kind of the scientific perspective where you really want to go very deep. This is supposed to be something fast that is intended to make quick decisions, but using scientific data. And in this case, for example, we look at sea level rise scenarios. We had somebody model connectivity through a corridor, and somebody else modeling using models to allocate different land uses. So very interesting process. And this, as I said, I mean, a lot of data, a lot of thinking goes at the very beginning of the process when you're thinking about what systems are we going to represent, how are we going to measure what is good or what is bad in that process. So for the last part of my presentation, I wanted to spend a few minutes talking about, geospatial technologies here at CED and how different people, whether professors or students, are using it. I'm not going to go into the details, or I'm not going to go into very in-depth descriptions, but I just wanted to kind of recognize what we are doing here at CED. So there is a whole world of technologies out there for collecting data, for drones, mobile apps, crowdsourcing, online data, LiDAR, you name it. There is another world of software and applications for analysis, for synthesis. And as you move up into the process, we get into more sophisticated frameworks like Geodesign, or maybe attempts to disseminate and collaborate through web mapping. No? I wanted to start with what the Cultural Landscape Lab has been doing for a few years now with the Geography Department, with the Center of Geospatial Research. And this is in the same area that I just mentioned before, in Wormflow. And they have been trying to reconstruct this landscape by using a combination of LiDAR, which is a remote sensing technology that allow us to have very dense point data clouds that give us elevation and give us also other properties. There is another application that they have been using, is called a structure for motion, and they use it also. It's a series of photographs that also allow you to reconstruct these environments. The Digital Humanities, and we have here Scott, who probably can talk a lot better about this project. They have a mapping occupation project. There is a link here. This is an example of a great online mapping application where you have, once again, a variety of data that they have, is backed up by extensive historical research of the occupation and reconstruction of the South. And you can see here, this is just one of many sections that this very rich website has, where you have, for example, census of Black population, and then you have, quantitative information about total number of troops and, other elements. So I invite you to really spend some time if you're interested in the topic. And then we have, and I see, again, you're here, the Center for Community Design and Preservation, who has been using GIS for many things. They have this program called Find It that basically has been conducting surveys of historical properties here in Georgia. And of course, they use GIS, GPS, mobile apps, online mapping, and probably more things nowadays. I mean, I'm sure that Jennifer can talk a little bit more about this. And then we have the work of our PhD students. And one thing that I wanted to highlight in particular, I mean, these are samples from some of the students, but I wanted to highlight, we have 4 students that are hopefully finishing this year. And I really wanted to highlight what they have been doing, because all of them are using technology one way or geospatial technologies one way or the other. So Mansi Parker, who is working with Jack Crowley, she's looking at future rail transit, future rail transit here in Athens. And she's using geospatial technologies to map accessibility to the stations, and also to map other elements of her proposal. And the basic idea, as you can read here, I'm sorry that I'm breezing through this because I know that we're running out of time, but she's looking at this from the perspective of institutions, and it's not only UGA, but other institutions that could, take advantage of it. So there are several components that go into this decision. Micah Taylor, who has been working with Brian Orland, is using a combination of augmented reality and mobile apps that he has developed to look at McIntosh County in Georgia, and trying to communicate, improve the communications of past and potential environments, including sea level rise. So he basically developed a mobile app that if you point into these markers, historic markers, it will bring in tons of information. He developed a survey that he conducted in the area, and he has several publications already that I didn't include here, but he has been very successful in getting his work out there. Lena Abdoni is basically using remote sensing, and she's bridging urban morphology and remote sensing. And she's doing that by studying the Bekaa plain region in Lebanon, and trying to kind of come up with an alternative type of classification that is based on urban morphology criteria, density, architectural morphology, land use heterogeneity. And the reason is because he's looking at areas, some of them informal settlements that are very difficult to survey with traditional methods. So she's using that, trying to come up with something that is going to be of great application for areas that are not like the US, that are data rich, areas that in other parts of the world that they are more limited in information, but they can use satellite imagery really to augment the type of data that they have. So she's using a type of remote sensing software that is called e-cognition, and she's developing a different type of alternative classification and trying to run through and validate that. So she conducted field work also with some very interesting apps. We have Nasim Resmanpur, who has been looking at a few cities here in the US from the perspective of how can we use or I guess account for new forms of tourism that are occurring for the newer generations, and how can we engage them in using more public transportation as almost as a part of the tourism resource itself. And so one of the things that she has been doing is not only focusing on traditional type of tourism inventories like hotels and other infrastructure, but more innovative, like Airbnb is an example of that. So kind of the tourist experience is different under these conditions. So she's using network analysis, crowdsourcing data, and data scrapping techniques to conduct her study. And then I wanted to highlight the work of one of my students, Jijo Zhao, who has been kind of, she's at her, I think you are what, second year, Jijo? So Jijo is at her second year, but she has been exposed to all kind of technologies that you can think of. So this is, for example, something that she did in a summer class that I offer in Advanced GIS, and she used LiDAR data to look at San John County in Florida, and she used that to come with different ways to look at both vegetation and also structures. She also has been looking at connectivity and landscape metrics, and she used software, three different type of applications: Circuitscape, Linkage Mapper, and Fragstat. And she's working with Professor Margaret Madden in geography. So this is another example of a collaboration that we're having right now. And she's looking at Florida and coastal Georgia, again, Chatham County. And then finally, she has been doing a couple of things. One is looking at another type of growing remote sensing, I guess, open source application that is called Google Earth Engine. And what Google Earth Engine is doing is that it allows you to really analyze, great amounts of information. In this case, she's looking at a few years of, but you can go back to the beginning of the Landsat era in the 70s, and something that probably will take you months to conduct before, you can do it in the matter of hours. So in this case, she's looking at, so this is the city of Savannah, and she's looking at these few years of change in the city, and you can clearly see how the city is expanding, towards I-95. And then finally, she's using City Engine to build 3D models of, a couple of cities, San Agustin and Savannah. And some of these newer applications, or well, not newer, but relatively new applications that Esri is offering, allow to, for example, look at the scenarios with different type of zoning. So it's not necessarily an analytical tool, but it is definitely a visualization to compare scenarios and possibly quantify. But ultimately, one of the things that Jijo is trying to do in her research is to use this combination of 2D and 3D metrics and urban morphology, kind of built environment and natural environment to come up with a strategy for this type of complex evaluations. So I mentioned at the very beginning, how I was trying to make a point, that now this is coming straight from an Esri publication on science. And well, they have all these broad range of GIS tools, artificial intelligence, big data, and all of these scientific disciplines. I know for a fact that they are trying to, even though they call it science, they are trying to bring planners and landscape architects to this. But interestingly enough, none of that is here. So my proposal is that we need to come back to the idea that planning and design really play a very important role in this advanced, we talk about data science and as a, deep learning and all these new technologies. And I think planning and designers need to start owning some of these technologies to improve, the design process. So the last thing that I wanted to bring, and I think I have 3 minutes for question after this. I brought 3 quotes from my PhD students. This is from Jinxian Lee, who is working with Eric McDonald, and she talks, I asked them, and it was not necessarily related to geospatial technologies, but I asked them, give me your vision of the future, or kind of the role that planning and design fields will play in the future. And I think all of them I highlighted because, of course, all of them agree in certain things that were relevant at that point. The planning and design fields will lead the world to build a more equal, smart, and healthy human environment in the future. PhD fellows will be able to explore the best way to achieve this goal through their research. Monse said planning is already a collaborative field, and in the future, I see it focusing more on producing solutions based on inclusivity and equity. Planners will further bridge the gaps between planning and other related fields to create tangible solutions through applied research. And finally, Micah talked about planning and design fields of the future will create planning spaces for inclusive, well-informed real spaces. The researchers in the field will continue to guide these planning spaces to include equality, considerations of a changing environment, and a smart use of technology. And I thought that, some of these quotes are very relevant to what we do. And I wanted to bring a couple of quotes that I think are visionary. They were actually written probably around the 70s, but I think they are really visionary. These are quotes from Laurie Jordan. And one of them is, the map of the future is an intelligent image. And the other one is, I would describe this map of the future as a photorealistic, intelligent 3D image that includes full GIS attributes, which I can interrogate, fly around, and through visualizing any format and dimension that makes sense to me, and have availability anytime on any device. So the question that I leave to all of you is, are we there yet? Probably not, but it's good to have a north in your life. And I think this is a great one. And I think we're probably close to it. I just brought, some of those great technologies that I know that are out there that we are still not necessarily researching, but that I encourage, those interested in the PhD program to embrace that. And here is my contact information. Thank you. And my apologies for going a little bit over the hour.